Hello everyone, my name is Snuffleupagus and I am a bot developer at RuneMate, and this will be a guide on creating a basic TreeBot. This guide will go over the basic concepts and structure of a TreeBot, how to create the logical flow of a TreeBot, how to code the TreeBot itself, and then a little bit of testing on the TreeBot. If you are looking for a guide on more advanced concepts, such as implementing a graphical user interface in your bot, using obscure parts of the API, or any more advanced Java programming concept in general, this is not a very good guide for you to be watching. So to start off, I will take a look at the TreeBot structure, and if you are completely unfamiliar with it, the TreeBot structure is a custom RuneMate bot structure to help bot authors move on from the basic looping bot. It represents a binary tree, and you can read up a little bit about those at the Wikipedia article, but I'll just give a brief explanation here. It starts off at a root node and then branches out from there with validate statements, and those will return either a true or false, so a boolean, and depending on that boolean, we will take one branch of the tree or we will take the other one. And it'll keep going through these validate statements until it reaches the bottom, and these are called leaf nodes. And these leaf nodes are where we will be actually performing tasks in our bot. The TreeBot structure provides quite a few advantages over looping bot, and for newer bot authors, I would say it's actually the most helpful because it helps guide you into good programming habits. Having these leaf nodes where you execute tasks gets you into the habit of only doing one task per bot loop. It also helps enforce a good logical thinking where you are using yes or no rather than more complex statements that can lead to spaghetti code, basically. It also helps with code readability and maintainability and a bunch of other things, but those are the main reasons why you will want to use a TreeBot structure. Now I will be giving you an introduction to the bot we will be making today. The bot will be mining iron near the Ardoin Monastery and banking at Castle Wars. So to start off, we will be going to this area and finding iron rocks to mine. And once our inventory is full of iron ore, we will use a Ring of Dueling to teleport to Castle Wars and use the bank to deposit the ore, teleport back to the monastery, and make our way back to the iron ore area and start mining again. So to start off, we're going to need a bunch of information to code this bot, and I've gone ahead and already gathered the information we will be needing here in a notepad file, and I will briefly go over with you what all of this means and how I plan to utilize it. First, I have this coordinate in iron region, and that is a coordinate right about here, and we will be using this to tell if we are anywhere near where we want to be if we want to be mining. Next, we have the in Castle Wars region, and this will tell us if we are anywhere near where we want to be if we want to be depositing iron ore or returning to the iron ore area. I also got some information about the bank chest we will be using to deposit our iron ore. This is the Castle Wars bank chest. And next up, I have some information about the rocks we want to be mining. So here we have rock color and then two coordinates, a northwestern and a southeastern rock area coordinate. the rock color is going to be what we use to determine whether or not we want to mine the rocks. Because as you can see, we have a rock over here called rocks, and that's a coal rock. We have another rock here called rocks, and that one's just permanently empty. And then over here are the rocks we actually want. So we define the area of the rocks we want with these northwestern and southeastern coordinates, which are this coordinate here and this coordinate. And then when we're actually inside of this area, we still need to be able to tell whether or not we want to mine any rock at a given time. Because once we mine a rock, they turn gray. They're depleted for a short time. And as you can see, they have the name rocks beforehand and the rocks name rocks after we mine them. So a good rule of thumb when you're programming bots is to only use information that is visible to you as a player or a human being. And there's quite a few different characteristics of these rocks that are readily available to us. There is the color of them, there's the name of them, there's the shape of them, there's the location of them. Some of the invisible characteristics to us would be the ID of the rock, which is 7,000 something, but using IDs is a last resort because it is something that we cannot view as a normal player, and if we strive to make our bots using only information that is readily visible to a player, that habit will carry over to other areas of our bot, and we won't end up mistakenly doing a very inhuman action. Well, I guess we still could, but if we're in the habit of it, it's less likely to happen. So that is why I decided to go with using the color of a full rock. And I will show you how to utilize that later. Next, we have the door when it is closed or open. And that is this door down here in the monastery, because we can actually teleport inside of this monastery area. And if we do that, and we try to walk to this iron ore, the bot can't do it. We just get stuck. We need to have the code to open this door and then walk up here and resume mining the iron rocks. The next piece of information we have is in the monastery, and we have two coordinates, again, northwestern and southeastern, and that is going to let us know when we are in this monastery so that we can detect that and open this door if needed. Finally, we have some information about the Ardoin cloak and the ring of dueling, and those are the items we are going to be using to teleport to Castle Wars to use this bank chest. And then once we deposit the items, to teleport back to the monastery and resume mining. Now that I have gone over the information that we're going to need to create this bot, I'm going to take you through making a flowchart to get a general idea of the bot's logical structure. Once you've made a couple TreeBots, you probably won't need to be doing this anymore, but since this is a tutorial on starting and making very basic TreeBots, I am going to take you through this process to get you a good idea of the logical flow this bot will be using. So the first thing I want to check is, are we somewhere where we can mine iron? So I got that. I'm going to exit out of the dev toolkit. I got that piece of information already and called it in iron region. So I am going to say, are we in iron region? And that will be our root node of our tree. the very first thing that we look at. And then depending on the answer to that question, the validate, we are going to either perform a task if we're at a leaf node, or go through and do more validates to determine what we want to do. So we take this, and let's say yes, we are in the iron region. The next check we want to look at is our inventory full? Because if our inventory is full, we don't want to navigate from the monastery to the iron. We don't want to mine any more iron. We just want to teleport to Castle Wars. So going back here, we will put that. Is our inventory full? And if it is, we want to teleport to Castle Wars. Okay, so here we have our root node, our first branch task, which will have a validate of is our inventory full in it, and then our first leaf node, yes, we want to teleport to Castle Wars if our inventory is full. Our next step is to answer the question of what we want to do when our inventory is not full. And this is where we need to determine the next logical step of our bot. Determining the logic of your bot can be a little bit tricky at first, but once you make a couple bots, you'll get a general hang of a logical flow that works for you. So I have found that my next step is to check if I am in the specific area I want to be in. We started off checking if we were in the general area, and then we checked if our inventory is full, but now we're going to check if we are in the iron mining area, because we know we do eventually want to mine iron. So, are we in iron region? So we're going to go back up to our original branch task and say that no, our inventory isn't full. Our next step is to check if we are in the iron region. So if we are in the iron region and we don't have a full inventory, we will want to find a rock and mine it. So I'm just creating the flowchart here. And now our bot's logic is first checking if we are anywhere near iron. Next, we check if we want to mine iron. And if we do, we check if we are near iron that we can mine. And the result of that, if we are near the iron, is to find a rock and mine it. If we aren't near the iron, but we are in the general area of the iron region, it means that we are either on our way to the iron, so between the monastery entrance and the iron area. We could be in the monastery area itself, or we could be somewhere random in the area. Let's say our bot bugs out and we end up over here. We still want to be able to account for that and allow our bot to recover by walking over here to the iron area. So back in our flow diagram, if we are not in the iron region, but we are in the... Oh, I actually have a typo here. This isn't supposed to be iron region. It is supposed to be the rock area. So if we are in the iron region, we don't have a full inventory, and we aren't in the rock area, we want to go to the rock area. and when we get here, there are two options of what might happen. Either we are in a position where this iron rock area is easily accessible, or we are inside of this monastery. And if we are in this monastery, we need to check whether or not this door is closed, because if it is closed, we aren't going to be able to walk over to this iron area without first opening it. So back in the flowchart, are we inside of monastery? If we are, our next step would be to check, is the door closed? If the door is closed, we want to open it. And I'm just going to get rid of it here because that is a very vague word. I would rather use open the monastery door. And if the door is not closed, we have no issues with being in the monastery, and we can walk to the iron rock area. And here I am going to copy my yeses and nos to make this more readable. And now we need to go back up here to, are we inside of monastery? Because we have everything branching off from yes, but from no, we're still missing some information. If we are not inside the monastery, not inside the rock area, but we are in the iron region without a full inventory, then we need to make this same action, walk to the iron rock area. So here we actually have a repeated leaf, and this is something we will address later. But it's somewhat convenient because rather than having two separate leaves, we can just make both of these branches point to the same place. So here we have a completed left side of our tree from, are we in the general iron region? Another way to look at this is as the mining portion of our bot, and what is to come will be the banking portion of our bot. So the first thing I'm going to put in the banking portion is checking that we're actually at the bank. So are we in the Castle Wars region? This is a good check to have because something unexpected could happen in the bot, like we could just run to Yanil. We have no idea why it happened, but it did. Or we could have a user do something silly and try and start the bot in Varrock West Bank. And this is something that will allow us to account for rare cases like those later on. But for now, we're just going to assume that yes, we are in the Castle Wars region. And since this is the banking half of our bot, I am going to make the next logical step. Is the bank open? So what we have here is the bank open. Everything after this is going to be determined by this validate. If the bank is open, we're going to want to do things such as deposit iron ore if our inventory is full, or withdraw a new ring of dueling if we need one. And if it's not open, we are going to want to decide if we want to open the bank, if we want to equip a new ring of dueling that's in our inventory, or if we want to teleport back to the monastery. So I'm going to start with the yes, our bank is open, because I prefer to do the true validates whenever possible. So the first thing I want to check is, do we have a ring of dueling equipped? And if we do have a Ring of Dueling equipped, then that part of our next trip is all set. And we need to check if do we have an I'll put a nearly empty inventory, 27 or more slots. And this is because we may have users who choose to run the bot with a pickaxe in their inventory rather than equipped. So if we are in the bank and we have, I'm actually going to modify this and just say have a Ring of Dueling whatsoever, because we may have withdrawn a Ring of Dueling and not equipped it yet. So if the bank is open, we have a Ring of Dueling, and we have an empty inventory, we don't want to be in the bank anymore. So we are going to close the bank interface. And now I am going to go back and do some of the leafs that will happen if these branch tasks validate returns false. So if we don't have an empty inventory but the bank is open, we are going to want to deposit everything except for our pickaxe and Ring of Dueling. So when you're making this bot, your first thought may be deposit our iron ore. But although that would almost always work, it's not as universal as depositing everything except for what you need. This doesn't really come into play all that much in old school RuneScape, but it could if you were to pick up an empty vial, let's say. This would allow your bot to deposit it rather than perpetually running with that empty vial in your inventory. This also comes into play a lot in RuneScape 3 with these strange rocks they have. If you're doing something like spinning flax, for example, and you get a strange rock in your inventory, you would want to code your bot to deposit everything except for what you need rather than just the bowstrings, because if you just deposit the bowstrings, that strange rock is going to be in your inventory forever. And next we are going to go back and say if we don't have a Ring of Dueling, we want to withdraw a Ring of Dueling with 8 charges. So that should hopefully cover everything we need when our bank is open and we are in the Castle Wars region. Now let's cover what happens if the bank isn't open. So our first step is going to be checking and seeing, do we have a Ring of Dueling equipped? If we do have a Ring of Dueling equipped, we want to check, do we have a pickaxe equipped? And if we have a pickaxe equipped, we want to check, do we have an Arty cloak equipped? And if we do have an Arty cloak equipped, we want to check if we have an empty inventory. And although that may seem like a lot of things at once, what I actually just made here is checking if we are ready to begin mining again. So if everything here returns true, if we are in the Castle Wars region, our bank isn't open, but we have a Ring of Dueling, a pickaxe, the cape we need, and an empty inventory, that means we want to be in this iron region. So we are going to teleport using our cape to the monastery. And I am going to go back here and add in all of the yes or no's to make this a bit more readable for you. Oh, here's another. So in time, when you're making these, you actually won't need to make this logical flow diagram at all, and you won't need to go through and add all these yes or no's to really spell things out. But as a beginner, this is a very good habit to get yourself in so that you can easily see the logical flow of a bot. So now that we have all of the yeses here done, we're going to go back one at a time and do the no's. If we don't have an empty inventory, we want to open the bank so that this will return true and we can deposit everything except for our pickaxe and ring of dueling. And now, do we have an Artie cloak equipped? If we don't, I am just going to stop the bot here because this is going to be one of the requirements for running my bot. And I'm going to do the same thing for whether or not we have a pickaxe equipped, because users should not be starting a mining bot without a pickaxe. And then here is the one that's a little different. Do we have a ring of dueling equipped? One of our banking tasks is withdrawing new rings of dueling. So if we don't have a ring of dueling equipped, rather than just stopping the bot, we're going to check, do we have a ring of dueling 8 in our inventory? If we do, then we want to equip the ring. And if we do not, we want to open our bank so that we can get a new ring out. So as you go through the bot, you'll notice that we do have some repeats here and there, like open the bank and open the bank. And is our inventory full? Do we have a nearly empty inventory? And that is generally okay, but it is an indicator, if you have a ton of these, that you may want to rethink your bot's logical structure. Because if you have repeated ones all over the place, it means that your bot is doing a lot of extra thinking that it shouldn't need to do if you code the logical flow of your bot a bit better. And optimizing that will make your bot run better for users. And all that's left here is deciding what we want to do if we're not in the Castle Wars region. So I am going to tell the bot to teleport, or first check, do we have a ring of dueling equipped? If we don't, I am just going to stop the bot, because something very unexpected here happened, and we could, if we wanted to, code the bot to handle this a bit better, but this is a pretty simple bot, so I feel that this is sufficient. If we do have a ring of dueling equipped, we want to teleport to Castle Wars. So a user could start the bot in Varrock West, and as long as they have the ring of dueling equipped, it will be able to recover by teleporting to Castle Wars and then going through the rest of this bot logic. So what we have here is a finished tree, and this is rather extensive for such a simplistic bot, and we could condense this a bit by having less branches where we validate things and handle a little bit of that in the leaves. But as a beginner, I find that it is helpful to really separate things as much as you possibly can, and that will allow you to easily go back and fix things later on. So our next step will be taking this tree and creating it in Party's TreeBot creation tool. So here I have opened Party's tree creation tool called the TreeVisualizer, and I am going to be converting this flowchart to a Java structure using this tool. To start off, we are going to replace the root branch with in iron region. So his tool allows you to make the file names and add a bit of detail about what it's going to be doing. And this really helps you with larger trees because it's easy to forget what different files with similar names are supposed to be doing. And it's also easy to forget the larger logical structure of your bot if you don't have a flowchart like the one we just made. So I am going to be adding a bit of details to each of these. Checks if we are in the general region of iron rocks. And update. So now that we have the root branch created, we are going to go through and do this right hand side. So I am going to add a success branch called is inventory full, and this is going to check if our inventory is full. And then from here, if our inventory is full, we want a success leaf called teleport to Castle Wars, teleport Sea Wars. So teleports to Castle Wars with a ring of dueling. Add. From this branch's inventory full, we have another branch, but this one is a failed branch because it has no right here. So this one is going to be called in rock area. And this checks if we are in the area we want to be in when we are mining iron rocks. And add. So now if we are in the rock area, we want to mine a rock. So mine rock. This finds a rock and mines it. So I'm just going to go back and fix this name real quick because the names of your classes should start with capital letters. In our branch in rock area, if it is false, the next branch we want is checking if we are inside the monastery. So checks if we are in the area immediately inside of the monastery. From here, if we are not inside of the monastery, we want to walk to the iron rock area. So walks to the iron rocks. And if we are inside of it, we want to check for a closed door. So I will name that is door closed, just to stay consistent with other ones. Checks if the monastery door is closed. And if it is closed, we want to open the monastery door. And that is going to be a leaf. Don't really need a description there. And if it is not closed, we can walk to the rock area again, just like before. But one shortcoming of the TreeVisualizer is that you can't create things with identical names. So I'm going to name this change to walk to rock area in all capital letters so that I remember I need to change this to this leaf later on. So at this point, it's good to go through and check that you have 2 indented after every collapsible option here. So I do, except for here, and this is to our root branch. So we just finished the left side of this tree. So now it is time to make the right hand side. And a nice feature is that this tool guides you through which ones you already have. I have a success branch, so it's not going to let me add a second success branch to our root branch. The failure branch is going to be in Castle Wars region. It checks if we are near Castle Wars. Add. And then from here, it is going to check if the bank is open. That is another branch because it has more things coming off of it. Add that. And then if the bank is open, we have another branch. Have ring. From there we have another success branch. I will call this nearly empty inventory. Oh, and you need to make sure to select it, or select the one you want each time. And from there we have the success leaf, close bank. And now we'll go back up through here. The failure leaf is deposit unwanted, to deposit everything except for what we want. Now we have 2, so we can collapse that, and we only have 1 here. So if we don't have the ring, we want to withdraw a ring. Now we have 2, so we can collapse that. We have 1 again. If the bank is not open, we want to go here. Do we have a ring equipped? So ring, have equipped ring. That is, we're back to branches now since there's new things coming off of this. And from this fail branch, we are going to go back to the success branches because I like to do those first. Have pickaxe equipped. Then we have cape equipped. Have nearly empty inventory. And if we do, we want the success leaf because it's a yes there. Teleport to monastery. Okay, and we have 1 success operation from here, so we need to add the failed. If we don't have a nearly empty inventory, we want to open the bank. Add. And now we're going to go back up just like we did before. If we don't have a cloak, we want to stop. If we don't have a pickaxe, make me stop. Just like before in all caps because we're going to replace that. Then have equipped ring. This one goes to a fail branch. So have ring in inventory. Add. If we don't, we want to, we have 2 leaves coming off of here. So make me open bank because we want to open the bank as our failure leaf, or as the success leaf, we have equip ring. So it can be a little hard keeping track of what you do or don't already have. Like I remember I have an open bank here already, but again, that's something that you'll get the hang of as you create more and more bots. So I just went through and collapsed everything where there was 2 coming off of it, and we are back up to in the Castle Wars region. And our failure branch here is failsafe have ring equipped. And we're going to have failsafe, or this is just stopping the bot here, so we don't really need to make a new failsafe stop. We can just do make me stop again and add it, and then the success leaf is going to be failsafe, or again, we don't really need to have a different teleport to Castle Wars leaf since it's going to be identical to the other one. So make me TP Castle Wars. Okay. So that should be everything we need for our bot. So I like to be a little precautious here. So I go back through and I expand everything and make sure that I didn't miss any of the branches or leaves. So in Iron Region, we should have 1, 2, 3, 4, 5, 6, 7, 8, 9 coming off of here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And from the failure, we're going to have, let's see, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we'll go through here and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we have everything. We are going to go to export and make a save file. We'll call this, let's see, Iron Monastery Mining Tree View. And I'm going to move this off screen so you don't see all of my files. I'll save it there. And then I am also going to export to Java Skeleton. And here I'm going to go to my D drive and create a new folder called Monastery Skeleton. So I have my computer, and then wherever you want it, you just want to make a folder and select that folder. And that's it. This tool just generated a Java skeleton of our tree. So here I have the folder that I just exported to, and you can see everything in here is a Java file. Now that we have the Java skeleton made, I will show you a quick and easy way to put it into your IntelliJ project. So I already made a folder here called Monastery Iron, and I am going to right click that and select Show in Explorer. And that is going to open up the folder inside of Windows Explorer where IntelliJ is finding the files. And I am going to take that directory and go to the one where I saved all of my Java skeleton files to, take all of them and move them over here. So now when we go back to IntelliJ, we have all of these files, and you will see that in each one of these they have errors. The errors are here, package, please add your package, import whatever paths, and then these themselves throw errors. An easy way to fix that is to right-click the package you have it in and select Replace in Path, and we will start off with the package name. So I will go to one of these files and type out the package path I want. So for me, that is com.regalbots.mining.monastery-iron. And that gets rid of that error. So I'm going to copy that and then go back to Replace in Path, if I can find it. There we go. And we are going to look for package, please add your package, typed exactly like it is here, and we're going to replace that with the package path that we just made. So here you can see a preview of all of these files, and these are all the files that it's going to replace it in, along with the line number, which is 1 for every file, find, and then all files. So now if we go to these, it replaced that, which solves our first error. Our second one is this import path to your whatever. We are going to take the beginning of this, import path dot, do a replace in path. We're going to look for that and replace it with a commented out version. So find all files. And just like that, we got rid of all of the errors that this was throwing. Now I like to condense this a little bit, which will make it much easier for us in the next little bit of the coding process. I typically organize it into branches and leafs for more simple bots, but you can organize it in any way you want, whether you want to perfectly mimic this structure as your folders, which I wouldn't recommend because that would get annoying very fast, but you could do it that way if you want. Or I have other bots where I put all object interactions in the same folder. And I have other bots where I have the beginning part of this structure mimicked, but after the first few branches, I just have them all dumped into the same folder. So now we go through each of these files and we look whether it extends leaf task, which means that it's a leaf, or extends branch task, which means that it is a branch. You can also look at the structure of the file here. If it has a validate, it means that it is a branch, and if it just has an execute, it means that it's a leaf. This execute is where you put the action you want your bot to do. So let's see. The first 4 of these are leaves, so I'm moving them to my leaf file. And IntelliJ will take care of all of the hard work for you. You just have to figure out which one is which is a pretty speedy process. Here we have a ton of branches all in a row. And this is partially because we stayed similar with names, starting them with have or is or in. It's good to stay as similar as you can so that you have an easy time, even without these folders, finding the file you want, because you'll have a good idea of what it's going to be named. Let's see. So all of these makes are leafs. Mine rock is a leaf. One of the nice features of IntelliJ is that when you drag it here and click refactor, if you take a look inside of these folders, the package name automatically changes. That's part of what refactoring is. So that is why we were able to replace them all with just this, and IntelliJ takes care of the rest for us. So we have a branch, and then the rest are leaves. So move those there. And this last one is a branch. And again, this is personal preference, but I like to make the root branch, I like to put it in the root directory of our package. So I am going to go back to in iron region and move it out of branches. So inside of our package, we have a folder for all of the branches, a folder for all of the leaves, although previously and our main class, our bot's main class. What this actually is our root branch, and we need to make a separate Java class as our main class, which will initialize our root branch. So I've made another class here called Regal Iron, which has a very simple layout. All it is the typical file structure where it declares the class with the name, and this class extends TreeBot instead of the looping bot that you're probably used to. And I have a little bit extra in here with the directions and current problems and all of this, as well as a note to myself section. This is just something I put in my classes to help stay organized. And all that we're going to have in this class is a create root task. And this is something that is going to get called behind the scenes to create our root task, which is at the very top of our flowchart. Are we in the iron region? So we put public tree task create root task return new in iron region, and when this method gets called, it's going to return the class in iron region to be created. So we make our manifest just like usual, and this Regal Iron here is the class we're going to point to as our main class. And now we can really get down to it and start creating our bot's logic. To start with, we are going to change the validate of the in iron region. To start with, we're going to change the validate of our in iron region to check if our local player is near this coordinate. So we're going to take this from our notepad of save data, and we are going to make this a coordinate inside of our file called in iron region equals new coordinate whatever. And in our validate, we are going to say if players get local is not null and the distance between in iron region and our player is less than, let's say, 50, we will return true. Else, we want to return false. And here we're going to make a private player called player and import that. and we are going to assign our local player to players get local. So what we just did here is we looked for our local player, we assigned it to the variable named player of the player type, null checked it, and then did a distance calculation based on it. And inside of this validate, we always need to return true or false. If we return true, we're going to go to our success task. If we return false, we're going to go to our failure task. So now we really just have to go through each of these classes and make our logic. So I am going to go through all of these branches first, and then all of these leaves. And I actually have an old version of this bot, which I am going to be referencing off on the side just to copy paste stuff where I can. Here we want to check for a nearly empty inventory. So we can return inventory get empty slots is greater than or equal to 27. So this looks a little bit different from what we had in our last class. Rather than having an if-else that returns true or false, we are actually going to return the result of this calculation. This is the same as the following code. If inventory get empty slots is greater than equal to 27, return true. Else return false. I'm gonna move this inside of here so that it's not giving me those ugly errors. So you'll see here when we have it written like this, if we hover over if, IntelliJ is telling us if statement can be simplified. And it gives us a little bit of details here, but with this foo instead of what we actually have. So instead of having this bulky code, we can just return whether or not this Boolean statement is true or false by itself. And using that principle, we can go through every class and make our validates. Here I have an array of any ring. We're going to return equipment contains any of this array, any ring. And this array is just an array of all of the names of a ring of dueling, 8 through 1 charges. You could do this a bit cleaner with regex, but when the application is relatively limited like this, I find that it's faster to just make a simple array because I'm not particularly well versed in regex. So here we're going to do return equipment contains, and we need to put the string of the cape we're looking for, which is, as we saved earlier, our Doan Cloak 1. Have equipped ring. We're going to go back here and take this array again and return equipment contains any of any ring. Now have nearly empty inventory. We want to return inventory get empty slots is greater than or equal to 27. have pickaxe equipped. So here we're going to need to make an array of pickaxe types. And I had this array stored in another bot, so I'm just going to copy and paste it from there. And return equipment contains any of pickaxes, or inventory contains any of pickaxes for any skillers out there. Now have ring is going to take this array again, and instead of just being equipped like before, we are going to have another similar validate where it looks for it in the equipment and in the inventory. Going to change this to any ring. And here we're going to look for a ring of dueling with 8 charges in our inventory. Now we're seeing if we are in the region again. So, oh, I can actually simplify this as well. Let's see. Return that. And fix the parentheses. There we go. So I'm going to copy all of this and go back to in Castle Wars region. We change in Iron Wars region, or in Iron region to in Sea Wars region, and we change the coordinate of it. So we have 2440, 3090, and 0 from our note file. And change that over. Now same thing here, except we're going to have an area near iron rocks. New area. Rectangular. Okay, so this is creating an area called near iron rocks using the northwestern and southeastern coordinate. I'm going to copy and paste these in from my data file. And rather than distance, we will do, since it's a small area, we're going to check if the area contains our player. And we're going to do something very similar to this to check if we are inside the monastery. In monastery. And we'll change this over. And we will also change these coordinates over from our data file. Next is bank open. We have a nice, easy API call. So we're going to return bank is open. And now is door closed. This is where we're going to have to use our first query. So we will, inside of our validate, do game object door equals game objects, new query names door, actions open on the coordinate that we collected earlier. And then we will call results first, since there should only be one, and we're getting an error here. Okay, so I think we need to make this a coordinate. So private coordinate door chord equals new coordinate. Yep, there we go. And we will return whether or not that door is null. So we look for a game object with these characteristics and assign it to the variable door, and we see if door has anything assigned to it. If the door exists, we want to open it as the success task. So we'll do, if it isn't null, we want it to succeed. If it is null, it means that the door is already open and we can just walk right to the area. Now, is inventory full? We want to change this to inventory is full. And then nearly empty inventory is going to be the same as this, but it's a different branch because we want different failure and success tasks here. So that is all of our branches. And now we are at the leaves, and at this point I change leaves from or I delete all of the leaves in all capital letters, and I go back to my branches and look for any errors. So here I have 2 errors because both of them were repeated. I will change this to teleport Castle Wars. And then I will do the same thing for here. I will make this stop, and let's see. We want to, oh yep, it is asking us to import it from Monastery Iron. That looks good. And then stop. And stop. So now I will go through the rest of these. Here's another one. So since I already did it up here, I can just copy and paste this, import it from the same place again, and change this to stop. Okay, private open bank. I'm gonna have to blur that out, that's annoying. Open bank. And in our Okay, so I just finished going through all of these and getting rid of the paths that I needed to change, and now we can go through and write the code for our leaves. So in here, we just need bank close. Nice easy API call again. And here, we're going to make an array wanted equals, let's see, okay, so this array syntax that I had earlier is actually unnecessary. So I'm going to go through and remove the extras that I may have had in any classes. I know I had more than one. Yeah, here's one. And here's another. Okay. So what we want is any pickaxe name and a ring of dueling 8. So I'm going to go back and copy all of these pickaxe names. And the array. And then do bank deposit all except wanted. Equip ring. Here we need sprite item inventory ring equals inventory. New query names ring of dueling with 8 charges. Results first. If that search doesn't return null, we want to equip the ring, which can just be done with a left click. Then mine rock. This is where we are going to have a leaf that's a little bit more complicated. We will start off with defining the color of the leaf, which is what we collected earlier. So the color of iron is this RGB. And then we want to find the game object we want to interact with. So the two stipulations of our query are that we want it inside of the iron ore area, and we want it to have the color of a full iron ore. So we look for a game object with those, and for good measure we throw in the names of rocks. And I'm going to move this withins forward because I believe that will make it the query a little bit faster. And now we only want to do anything if we have a mineable rock to work with. So I'm going to make a delay here by creating an int of our called mining xb before skills skill mining get current experience. There we go. Then we want to check if the mineable rock is visible. We want to interact with it by mining it. Let me make sure that's the right action here. Yes, it is. And then we want to delay our bot until the rock is no longer valid. which we will do like this, or until our mining experience is greater than our experience a little bit ago. And we will add in a minimum of 200 milliseconds and a maximum of 15 seconds for that delayed timeout. And now, if the rock is not visible, we want to turn our camera to it. And if the rock is null, we will print out a message saying that it was null so that we can refer back to this in the future and figure out why that happened. So the rock we looked for in mine rock was null. Okay, so that should take care of finding a rock to mine and mining it. And now when we open the bank, it's going to be pretty similar to mine rock, or yeah, so we need to, it's actually going to be closer to the door where we need a coordinate that the bank is on. And we have that saved from earlier. The bank chest is on the coordinate that I'm pasting in now. So game object, bank chest, new query on bank, names of bank chest, actions, use results first. If our bank chest is not null, we want to interact with it and then delay until bank is open. We want to reset the delay if our player is not null and player is moving, then we'll have a minimum delay of 100 and a maximum of 1,000. We'll have a variable of the player type called player and assign it here. Okay, and there we go. And it's telling us we can replace this with a method reference, but I don't like doing that. So here we also need to add in if bank chest is visible. Else camera turn to bank chest. And then again, I'm going to add a printout that lets us know that the bank chest was null. And this is just for future debugging purposes. Okay. And now, something you saw me do here is I put if the bank chest interact, I put bank chest interact inside of an if statement, and that's because this interact will only return true if the interaction is successful. So this delay won't happen unless we actually interacted with it. And that's something we actually want to do here as well. I have a bad habit of not doing this, which I'm trying to fix. There we go. And now we can go back to here, get the information for the door. Let's see. Re-execute this query. Say if door is not null, if door is visible, if door interact open, execution delay while door is valid with a timeout of 1.5 seconds. Else we want to turn the camera to the door. And else we want to let ourselves know that the door was null. Okay, here we just want to stop the bot. Here we want to use the ring we have equipped to teleport to Castle Wars. So we'll take this array, copy paste it over. And in the execute, we will do this. Let's see. Player equals players. Get local. And back up here in Castle Wars region, we will take this. Actually, we can just copy all of this over and take what we need. So we will delay until players get local is not null, and let's see. Okay. So what we have here is we don't actually need this here. So we can get rid of that. Get rid of this extra. So we look for a dueling ring in our equipment. If it's not null, we want to interact with it to go to Castle Wars. And then we delay until our player is not null and in Castle Wars. And just for good measure, we could throw in get animation ID is -1, which means we're not animating anything. And then we're going to have something very similar here. So I will copy paste this over. We want to import all of these things. So we don't need any ring. Instead of the Castle Wars region, we want to see if we are in the Iron region. So I will copy that over. Change this. And rather than a ring, we are now looking for a, let's see, Ardone Cloak 1. I believe that is right, but I actually did not write down the name of the cloak. So let's see here. I'm looking in my old version of the bot. Okay. And we could leave this as Dueling Ring, but I'd rather rename it for clarity. And we are not going to interact to go to Castle Wars. I'm going to interact to go to the monastery. Okay, that looks pretty good to me. And now we need to walk to our rock area in here. So we have those coordinates from earlier. We're going to make a private area, rock area, is a rectangular area of the coordinates that we have right there. We're going to copy these over, delete this, and here's where we want to make a path. Equals region path. Coordinate. Then, if the path is not null, we want to walk the path, and if the path is null, we want to know for debugging purposes. Okay, let's see here. Okay. And then here, we just want to withdraw a ring of dueling with 8 charges. End it with a semicolon. Oh, and we need to specify a quantity. Okay, and I believe that is our finished bot before any testing. Alrighty, we are back, and in my bot I have made one change, and that is to this mine rock leaf. I have changed the way that the game searches for the mineable rock by using color substitutions of the empty color, which is just 48, 48, 48, and then the iron color, because my original query was returning null. When the bot is playing, it mines the iron rocks, and then it is attempting to teleport to Castle Wars using the Ring of Dueling. It's detecting that it's there, and it is interacting with the bank booth. Deposits all of the iron ore we have, closes the bank, teleports back. It's walking to the iron area. And it has resumed mining some rocks. So we have just successfully made a very basic TreeBot. And the structure of it may not be the best, and the logic can definitely use some improvements. But at the end of the day, we do have a working bot that could be released publicly. There are some changes that I plan to make to this. The main one is that I'm going to make it rather than always walk to the iron area before mining after teleporting back, I am going to make it somewhat randomly either click the rock if they're already visible from far away, or decide to walk to the area first before clicking the rock. I am also going to add some improvements for the banking, because I know from previous experience that when you teleport to Castle Wars, sometimes on lower resolution monitors, you are not actually able to turn the camera to the bank chest. So I am going to need to add in a stipulation where if the bot is unable to turn the camera to the bank chest, we will build a path to it and walk a little bit closer and then try again. Other than that, all this bot really needs is some additional randomness and eventually a UI, but I will cover those things in future tutorials. For now, I hope that you have gotten a better understanding of a TreeBot and how to put one together using the resources that are available to you. And please let me know if you have any questions or suggestions for additional tutorials. Thanks for watching.